Lesson 11. Selected problems from NECO Part 2. Example 31. If the radius of parallel of latitude is 4,500 kilometers, find the latitude correct to the nearest degree. Take radius of the earth equal to 6,400 kilometers. Solution. Note that latitude of a place is measured in degrees north or south of the equator, which varies from 90 degrees north to 90 degrees south. By this note, option A is out, option B is out, option D is out. We have C and E remaining. Radius of parallel of latitude is given by this formula. The radius is 4,500 kilometers. Radius of the earth is equal to 6,400, then cosine of the latitude. Divide both sides by 6,400 to make this term the subject. When you divide, you have 0.703125. To get the required latitude, take the inverse of cosine of both sides, and you have 45.3218 degrees. To the nearest degree, you have 45 degrees north or south. The correct option is C. Example 32. Calculate the circumference of the parallel of latitude 60 degrees south correct to 3SF. Take radius of the earth equal to 6,400 kilometers and pi equal to 22/7. Solution. Circumference is given as 2 pi r. In this context, the small r is the radius of parallel of latitude given as the product of the radius of the earth times the cosine of the angle of latitude. You have 2 times 22/7 times radius of the earth times cos 60 degrees. This expression simplifies to this, and you have this result. To 3SF, you have 20,100 kilometers. The correct option is B. Example 33. An aircraft flies from P latitude 12 degrees north, longitude 11 degrees west to Q latitude 12 degrees north, longitude 11 degrees east in 2 hours, and then changes its course and arrives at S latitude 44 degrees north, longitude 11 degrees east in 6 hours after leaving Q. Calculate correct to 3SF the A part of the question: total distance covered, B average speed of the aircraft, C time difference between Q and S. Use pi equal to 3.142 and radius of the Earth equal to 6,400 kilometers. Solution: we need to locate the various points on the Earth surface. So you draw the Earth as a sphere follows by the two principal axes, north, south, east, west. You draw the equator, latitude 0 degrees. We have two other latitudes, 12 degrees north, 44 degrees north. Starting from the equator, the first one is 12 degrees north and the second is 44 degrees north. Now we have two longitudes on different sides of the prime meridian. Let's draw the prime meridian on the east side. It can be on the west as well. That is longitude 0 degrees. Then you draw longitude 11 degrees east and longitude 11 degrees west. From the reference point, if you move to this point, that is latitude 12 degrees north, longitude 11 degrees east, you have point Q. From the reference point to this point, you have point S, 44 degrees north, 11 degrees east. And from here, if you move to this point, you have point P. Same diagram you have here, the Earth as a sphere, the two principal axes, the equator, latitude 12 degrees north. This is 44 degrees north. You have the prime meridian, longitude 0 degrees. This other one, longitude 11 degrees east. This longitude 11 degrees west. So this is point Q. You have point S and you have point P. The solution continues. Since distance along small circle is not specified, by default we are to use the formula for calculating distance along great circle. Such a distance is given by this formula. A part of the question, total distance covered is equal to distance PQ plus distance QS. Distance PQ is on the same latitude but different meridians. So angular difference theta is 11 degrees plus 11 degrees. Different sides of the meridian, you have 22 degrees. Distance PQ becomes 22 degrees over total angles times 2 times pi times radius of the Earth, which simplifies to this, and you have 2,457.742 kilometers. Distance QS is on the same side of the meridian. So angular difference is through subtraction, and you have 32 degrees. You come here and you replace the various parameters with what they stand for. You have it in this form, and that is 3,574.897 8 kilometers. Therefore, total distance becomes the addition of the two distances. You have it in this form, and it is approximately equal to 6,030 kilometers. B part of the question, average speed. It is equal to total distance over total time. That is this value divided by 8, you have these results. To 3SF, you have average speed to be 754 kilometers per hour. C, time difference between Q and S is simply equal to 6 minus 2, and that is 4 hours. End of lesson 11.